Welcome to Module 3, Lesson 2. So, the explanation of what we need to talk about today is kind of long and kind of lengthy and breathy. So, I've kind of simplified it down to what's right here behind me here. And at first glance, it's like, what? I will explain it. So, what we'll be talking about is how we can relate and understand that 5 times n plus n is equal to 6 times n, which is equal to n times 6. What does that mean? What element? When first looking at this, you are going to be confused. You're going not sure what's going on, and you're like, what? Please help. So, at first, let's ignore this first part. Let's completely ignore that. And we have 6 times n plus n times 6. So I'll move that down here. So we're moving into a little bit of algebra-esque kind of stuff. If you have an older sibling, you may have seen something like this. If you have not seen algebra, algebra is a type of math that you start to kind of do late into elementary school, starts to hit heavy in middle school, and you do it a lot in high school and higher. And the idea is that you start using numbers, and we kind of already started doing this lightly to represent other numbers. And we use them to represent a basic equation. So, give an example here. 6 times a number is equal to that same number times 6. So if I were to come down here and say that n is equal to 3, I should be able to input it into this equation and have it equal the same thing. So let's check. So 6 times 3 would equal to 3 times 6. Now, we are going to solve this just to prove a point. But you should already know that these are equal to each other because of the commutative property. By using the commutative property, you know that 6 times 3 is equal to 3 times 6. We know that. We don't need to prove it because we've done it time and time again. But let's do it just in case. Skip count by 3 6 times. 3, 6, 9, 12, 15, 18. Or skip count by 6 3 times. 6, 12, 18. They both equal 18, so it works. And I should be able to replace n with any number. So n could equal 4. So 6 times 4 is equal to 4 times 6. We should agree on that. Commutative property. For just kicks and giggles, we can say n equals 187. 6 times 187 is equal to 187 times 6. I don't know what that answer is off the top of my head, and that's okay. All I need to know is that they equal the same thing, which means if I solve one, I automatically know what the other one is. So, going off of that, we now understand that 6 times n is equal to n times 6. And n is representing any number. And just a heads up, if this n is 3, that means this 3n has to be 3, and these n's have to be 3. Keep in mind. So, this is important because you'll get to a later point where you'll say like a plus b equals c. And it'll be like a equals 3 and b equals 4, and then you'd say, I almost said a again, 3 plus 4 equals c, and then you would say c equals what those add up together, which would be 7. And so and you know that a and b are separate because it says all a's are 3, all b's are this, and then all c's in this problem will be c. When we go to the next problem, if it's not the same problem, those numbers will be different, of course, but kind of keep that in mind. But now we've used this as an example. We'll even keep the n equals 3 part to prove this next part. We know that 6 times 3 is equal to 3 times 6. So what about 5 times 3 plus 3? Because remember, if this is 3 and this is 3, that means these two have to be 3 based off of the information we have here. So we've already determined that this equals 18 and that equals 18 if n is 3. We've solved that, we've figured out, we've agreed with that. Now we need to determine, does 5 times 3 plus 3 equal the same thing as 6 times 3? Let's solve it and figure it out. So in math, you always do multiplication first. You will never, ever, ever do 3 plus 3 before 5 times 3 unless there's parentheses right there. Then you do 3 plus 3 first. But do I have parentheses there? No, so by default we do 5 times 3. So 5 times 3, skip count by 3, 5 times, or 5 3 times with the commutative property. I'll do that one since it's faster. 5 10, 15. So that would be 15 plus 3 equals, hey, look at that, 18. Now the question is, how? How is that happening? I don't understand how that's happening. How does this equal the same thing? And we can enter any number here, n equals anything, and it will give you the same outcome. 6 times 4 is 6, 12, 18, 24. 5 times 4 is 20, plus 4 is 24. Same answer. Anybody asking, well, how is this consistent? How is this always the same? Because they're different problems, right? Well, you're not wrong. They are the same, or they are different. But let me explain to you how this works in a word problem. So I'm going to move the n equals 3 into the middle. So I'm going to say the 6 is representing how many groups we have. So 1, 2, 3, 4, 5, 6. And I say that there's 3 in each group. So I'll go ahead and fill that out as well. Now I'm going to use this same picture to represent every single one of these problems. You're going to ask, well, how? I might be able to see these two, but how in the world are you going to do this one? Let me show you. Right now, this is 6 groups of 3. 1, 2, 3, 4, 5, 6 of 1, 2, 3. So 6 times 3 if n equals 3 here. N times 6, or 3 times 6, because of this right here, you just take this and turn it sideways. So if you're looking at it sideways, you say there's 1, 2, 3 groups with 1, 2, 3, 4, 5, 6 in each. Once again, I'm not going to just pick the entire thing up right now. I've done that before. I'm not going to do it again. But if I take this picture and turn it, it would be showing 3 groups of 6. But how does this show 5 times n plus n? So n is representing 3 here. We are agreeing on that because we've said it's 3. 5 times 3 would be our first equation we did, correct? So how many groups do we have? We have 5 groups of 3. I'm going to draw that line right there. 1, 2, 3, 4, 5. 5 groups of 3. Plus 3 more. Plus 3. So basically, if we wanted to take this a step further, you could say that this entire thing right here is 5 times 3. And down here is 1 times 3. What's 1 times 3? 3. So technically, you could say 5 times 3 plus 3 will give you the entire thing. And wait, let's look at that too. If I were to erase that line and just do it straight up all together, how many groups do I have? 1, 2, 3, 4, 5, 6 groups of 3. Crazy, isn't it? It's kind of weird, but at the same time really cool how this works. And on your own, if you want to try this on your own, you're more than welcome to. Test me on this. See if I'm right or see if I'm wrong. Change n. Say n's 2 or 3 or 1 or 0. Do you guys want... let's try 0, because sometimes that's a question that I get a lot. What about 0? Well, let's try it. Let's say n is 0. So, let's say I have 6 groups of 0. 6 times 0. Well, what's 6 times 0? 0. Alright. What's 0 times 6? Well, it's 0. Alright, so those equal each other, so 0 equals 0. We agree on that. Okay, so 5 times 0 plus 0. What's 5 times 0? 0. What's 0 plus 0? 0. Weird, isn't it? But at the same time, it's really, really cool. And that's kind of the primary thing we're going to be talking about. But just kind of take us a step further. Using this idea, along with last lesson, I'm going to ask this question. I'm going to say, how is 7 fives, is that or is that not equal? I'm not going to put that there yet because I want us to determine this. Is this the same as 3 sevens plus 2 sevens? Are those two things equal to each other? And can we draw a picture for this? Yes, we can totally draw a picture for both of these. And if you need to, that's great. I'm not going to do it right now just because I'm going to show you another method. But if you wanted to, you could draw 7 rows with 5 in each over here. And then draw 3 rows with 7 in each plus an additional 2 rows with 7 in each. Now, I'm going to show another method of this. I'm going to make this look similar to this over here. Now, I have 3 7s plus 2 7s. Does the 7s change? Are we changing the amount in each group? No. So if I had 3 groups of 7 and 2 groups of 7, if I combine them, how many groups of 7 would I have? I would have 5 7s. Now my next question is 7 5s equal to 5 7s? Now think of the commutative property. Normally, we view commutative property as looking like this. Can we make these look like that? Let's see. So 7 5s, what does that look like? So I'm doing another step here. 7 5s becomes 7 groups of 5, or 7 times 5. And 5 7s becomes 5 times 7. What do we know about the commutative property? 7 times 5 is equal to 5 times 7. Well, 7 times 5 is just another way of writing 7 5s. And 5 times 7 is just another way of writing 5 7s. So are those two equal to each other? Yes. And we can take it a step further. 7 5s is 7 5s. You didn't change much there. But did we decide over here that 5 7s is another way of showing 3 7s plus 2 7s? So they're the same thing, right? Which means 7 5s is equal to 3 7s plus 2 7s, because it's the commutative property. Now, this is kind of the primary thing that we're going to be doing today. Main thing you will be doing kind of in your homework is just kind of practicing this and visualizing it. It's not too different than what you guys done in the past math-wise. It's just kind of looking at it through a different lens again, and we're going to be doing that a lot throughout the years. That we're doing the same math, but looking at it slightly different, because looking at it in a different way is going to help you later on in math. So that being said, hopefully this was helpful. Hopefully you guys learned a little bit from this, and I hope you guys have a great day.